spacesuit one's interesting. Let's just have a quick.
They said they've resolved it.
They resolved it, have they?
They haven't resolved anything. Yeah, and they put another girl in a spacesuit, and they put a couple of PSI inside the suit. It's talking about how she has to be trained to be able to handle the increased pressure in the suit. Well, of course, if you're in Earth's atmosphere and you put a couple of PSI in, that shouldn't have much of an effect, because if you dive into water, you'd more than double that just diving in. Just dive into a swimming pool. You only go down 8 feet and you've got more pressure than that. Anyway, she was sitting there trying to operate the gloves, and she was able to make an OK sign. That was it.
Oh, she's going to have trouble in space.
Well, yeah, there's all of that stuff that they're worried about. And then, of course, the last bunch of CMEs we've had.
Oh, yeah. Yeah, it's good, that.
And, I mean, this guy is describing it as very close to a Carrington event.
It was just short of a Carrington level event.
Yeah, the funny thing is our satellites don't seem to be affected by this. I mean, we've got this undersea cables running around the world that's providing all of our communications. So they're really not necessary to have.
Undersea cables, they're not going to get affected.
No, of course not. They're not in space.
Not only that, what I would like to see is the engineers that are producing all these new fancy spacesuits to do a ballistics test on them, and let's see a tiny little grain of sand go through that suit at 15,000 miles an hour. That's what I would like to see. We've never seen that before, ever.
Or 50,000 miles an hour, or 150,000 miles an hour.
Well, we have to go on what they claim.
Yeah, something like that.
Look at that.
Yeah. And continues on.
That's serious stuff.
So you're telling me that those layers in that spacesuit are going to withstand this, even if it's made out of Kevlar?
So if you're in space and somebody drops a monkey wrench and you go up there and it hits you at 15,000 miles an hour, you are history.
Now, this is not a magnetic. This is gas. They're using gas to fire it with.
Okay.
That's fair enough. Certainly creating a lot of damage.
Those are metal plates.
Yeah, and the hole gets bigger and bigger as it goes through.
Are the spacesuits made of metal plates? No, I don't think so.
No, they're aluminum.
This is a steely going through Kevlar. So they're firing different materials in different sizes into these plates and Kevlar. I mean, my God, if something hit those astronauts, they would be so dead. Look at the explosion from this. I mean, it just tears everything apart.
Well, imagine if you're out there and you're traveling at 17,000 miles an hour and something else is traveling at you at 17,000 miles an hour right at you. Now you're at 34,000 miles an hour. And these guys are dropping tools out there, so-called, that are a hell of a lot bigger than that. And satellites that have broken apart, that have been hit, and they're debris traveling at that speed. I mean, the best simulation I think they did in the movies was Gravity, wasn't it?
Yeah, I think it was. Yeah. Talking of fireballs, did you see the fireball coming in over Spain yesterday? Came across Spain and Portugal. Blue fireball lights up night sky in Spain.
That's very much like the one that was shot in Russia there.
Yeah, similar to that. The point about that is that they say it went in across Spain and Portugal. That is going from east to west. Now, any satellite in Earth orbit is going from
the other direction
to east. So if you get those two coming together, as you say, it's going to be double the speed, and it's going to just destroy it.
That thing looked low enough, it probably took out windows and stuff when it was coming down, the same as what happened in Russia.
I think that was filmed fairly high above the ground, because it went out over the Atlantic Ocean and hit the Atlantic Ocean at some point.
Then it was large enough not to completely burn up.
This just came out of nowhere. I mean, all of a sudden, the camera's just there, and it just goes whoosh like this. Oh, jeez.
I mean, it was quite low. It would only start burning up like that if it was in Earth's atmosphere. So it's less than 60 miles up, below the Kármán line, and nobody saw it. Good thing it didn't hit anybody.
Yeah, but this goes right back to what we were talking about with the spacesuits. All you would need is a tiny little grain of that to break off and hit an astronaut, I don't care where they are, if they're outside the ISS or they're on the lunar surface, it's not going to matter. That's going to go right through and out the other side.
That meteorite, or meteor, whatever it was, I mean, it could have been as small as a grain of sand burning up. It was moving quite fast. If that hit anything, it'd be history.
Well, if you take a look at an airplane, and it takes about 6.5 minutes to cross the sky, and that thing is doing it in 15 or 20 seconds. You could take the speed of an aircraft and see how long it takes to do it in 15 or 20 seconds across the sky. It's in thousands of miles an hour.
Yeah, it is. And it's coming towards all the satellites in the sky.
But how are those layers that are inside of that suit, how are they going to protect something like that if those little particles are going flying right through 7 layers of Kevlar?
Not.
As the material degrades as it goes through, it makes a bigger hole on the next layer, is what it's doing. That one that hit the glove and left the hole in the glove, he wouldn't have a hand, never mind be alive.
I think the only thing that they're going to be protected against in their spacesuit is the dirt thrown up at the wheels of the rover. But if it's coming in from space at huge speeds, which they will do, it's not going to stop that at all. As you said before, space is a very dangerous place for humans. We're not designed to live there. We're not designed to go there. We can't protect ourselves from the dangers of it. The idea that we can have some sort of spacesuit that protects us against grains of sand traveling at 15,000 miles an hour is ridiculous.
Well, look at Halley's Comet. It's 5 times faster than that.
Yeah, it's going very fast.
What happens if the moon is rotating this way and the particle is coming in that way? Now you're going to be doubling the speed, aren't you?
You are, of course. The moon is traveling quite fast through space anyway. It's rotating once every 29.5 days or whatever it is, but it's still traveling through space. And if the meteor's coming from the other direction, it's going to make a bit of an impact. That's why there are more craters on the moon than there are grains of sand almost, because they've been doing it for billions of years, we're told. I'm not sure it's true. The moon may well be an artificial construct designed to stabilize Earth and to allow life to exist. That makes more sense than the fact that it was a wandering planet or planetoid captured by Earth's gravity. That makes no sense at all.
We are an anomaly, that's for sure.
The moon was tailor-made for this planet. That's as simple as that, you know.
The Earth was tailor-made just for
life. Is there any other planets out there that have belts like Earth does? Have they detected anything? I mean, they should be able to. They have that big new telescope out there, the Kepler telescope. Do other planets have a magnetosphere? Have they found any? Yes, Jupiter has a very strong magnetic field and trapped radiation environment. It is said that if you could see Jupiter's magnetosphere, it would appear from Earth as large as the moon.
The planets with a magnetosphere apparently are Mercury, Earth, Jupiter, Saturn, Uranus, and Neptune. Each have an intrinsic magnetosphere due to their internal magnetic fields. Venus and Mars, on the other hand, lack a global magnetic field, which might have been responsible for Mars losing its atmosphere due to solar wind sputtering. So Earth has a magnetosphere, but Mars and Venus don't. It's almost like somebody's designed a whole thing for us to get interested in, and when we're intelligent enough to work out what the hell's going on, we might be able to get off the planet.
Well, that's interesting because our magnetosphere protects us from anything coming in that might kill us. It also protects us from being able to escape Earth.
Yeah, it works both ways, doesn't it?
Yeah, it does. It works both ways, keeping us alive here.
Yeah, they all seem to work the same way as the magnetosphere on Earth. They get affected by the solar wind.
Well, being that we can't find anything much about it, we'll just have to wait for the movie to come out.
Oh, your cynicism, Scott.
Speaking about movies, what about this new one that is going to be on the moon landing hoax?
Oh, yeah. Fly Me to the Moon. It's supposed to be released in July.
Yeah, it should be a good one because I think it's a comedy.
Well, the whole moon landing's a bit of a comedy as well, so matches well.
I hope they take advantage of the latest technology and blunder with it incredibly on that movie.
Well, I got Magic Mike there, so it must be true.
Well, when they did Space Force, that little series, right? It was Space Force, and he keeps accidentally hitting the button. Oops, boop. Oh, don't worry, we got a bunch more. We got tons of money. Just keep spending it. Oh, hit another one. Off another one goes. And the girl running around picking the lizards up. Environmentalists, you always have to have those in there.
And they should have got Kubrick, like they said.
Yeah, that was the one comment that they made in there, right?
It was a nice little touch, that one.
I still can't believe I never seen that before, that Apollo 17 EVA-1 at the geology station. So that's Apollo 17 EVA-1, Geology Station 1. And yet, that's pretty level ground where they are. And that camera swings around, and it goes all kind of wonky there. And I wonder when the camera's spinning around like this, it's going to wiggle the rover a little bit. And I'm wondering if that's why it cuts out and cuts in and cuts out and cuts in. But yet, get this. These guys can bump the rover. They're up against it and pushing it and everything else. And yet the picture's rock solid. And yet when the camera is shaking, moving around, the picture goes in and out. Strange, isn't it? I'm looking at it and the ground is so flat. So there's no excuse for those shadows to be changing from left to the right just at one swoop of the camera. That just doesn't make sense. And then look at the shadows before the camera swings around, how short they are. And then when the camera gets to the other side, the astronauts' shadows are so long that they go all the way from the hill right to the rover and past it.
Yeah, there's always a problem. It doesn't matter where you look in these things. Once you start seeing this stuff, there's no way to avoid it anymore. It's everywhere. And there's absolutely nothing that NASA can do about it. Nothing. They try to correct one document, they will screw up a dozen more because all of that information is combined throughout many documents.
Well, I know what's going to happen. As soon as Artemis 3 finally does make it there, who knows when that will be, but eventually they'll get there. And NASA's going to put out something like this. Well, we did get there, but we had to fake all these photos and films because they were wrecked. Because of the cosmic radiation ruined all the film. I'll bet you this is what they're going to say. For this to slowly come out of the box, I think that's what they're going to do. They're going to ease people into it.
Well, maybe this movie's going to be the start of it.
But it's a comedy, though, I thought.
Yeah, so why not make it a comedy? If they're making a movie, make it a comedy and start revealing a few of the things that people go, oh, yeah, this is this and this is that.
Well, I hope it's going to be something like Space Force. I mean, they really made a mockery out of the Apollo missions by doing what they did.
They're probably using the new NASA studios that they're building to do all the CGI and stuff like that. You got to wonder who's doing all the graphics for them to make these movies. And NASA's got a lot of movie studios.
But you don't need a big studio to do graphics anymore.
No, I know. But if you wanted to spend $3.5 billion on a zero-gravity simulator, you better use it somewhere. Why not in the movies?
You don't need astronauts hanging on wires anyway. If you have an optical printer, that is a piece of cake to do. There's no wires required on anything. Let's say that they did that in Apollo and they used wires. They're not going to be using wires in a lot of the scenes, I guarantee you that. So, for example, how would you make the rover look like it was going on forever and ever? Well, you have a set already there. You have all the craters blown, you have the crane that's right above the craters, and you have a shack there with all the power that you need. So all you would do is you would take the rover, set up the high-speed camera, and then you would slow down the rover. You would make the rover go very slow as you're going across the terrain. And by the time you speed that up just a little bit, it's going to look like you're traveling on forever and ever. So you don't need a big sound stage to do that. You want to do it the simplest way. That's the point here. In the new spacesuits, I wonder if they are using Kevlar to build up layers of Kevlar in those suits, because Kevlar you'd think would be a good material for that. But then, as we've just seen, when they fire a tiny little ball at it at 15,000 miles an hour, that Kevlar goes right through all those layers. So it's not going to work. And here's another problem. Let's say that they decide that they're going to dig a hole or dig into the side of a mountain on the moon and then put a base in there. Well, you're still on the outside for a little while. So what are the chances of you getting pulverized by some of this debris? It's just questions that you have to ask yourself. Why is it on Mars it's the same thing as these bases that they put on the moon? They always have to have a skylight. They make these domes out of this radioactive proof material, and then they put a window, a skylight in it. And when you look at the bases on Mars, the ones that they do in these CGI animations, they have windows in them on the top. They have skylights. I really don't get that. And then I said in one video, I says, well, maybe they'll put that mesh in the skylights that they have in microwave oven doors. And then I put a sample of it up there. And then what did Phase 52 do? It goes and makes a video about it. And then he says, microwave oven doors? Why would you do that? Oh, my God.
Don't try and understand it. They're just very, very sad people.
Well, I think that's to stop the radiation from escaping and cooking your eyeballs when you're looking in the oven trying to see if your meal's ready or not. Yep. But they don't get that. They don't get it.
But you see, that's what happens when you work at NASA. You go progressively more insane because they've got to maintain their story. They've got to pretend that they got to the moon. Anybody who says they didn't, obviously they've got to be attacked. So that's what they do all the time.
All this new technology that they're making, and yet they never needed it before.
No, quite amazing. The whole thing is absolutely extraordinary.
15 fuel tankers to get to the moon and back, and yet they did it with one Saturn V vehicle.
Yeah, I keep listening to the weight on that when they were talking about that. They were talking about Apollo was only lifting 45 tons.
Destin from Smarter Every Day had the figures between the two ships posted there.
Yeah, Apollo, a Saturn V rocket was supposed to lift 140 tons. And they're saying 40 or 45 tons. That's all the Apollo missions were. And I've seen that now in a few documentations on that. Because the new rockets can't lift any more than that. He can't lift 50 tons yet.
But 45 tons was what it weighed when it went to the moon. Not when it was in low Earth orbit. Because that had the extra rockets as well.
The translunar injection. All that fuel. And that's why they have to have 15 more rockets up there to fuel it up just to do that.
Why didn't they have that on Apollo? Don't get it. I don't think NASA does either.
I was looking at the Apollo 9 video footage of the LEM and the command module that were circling the Earth. And I'm thinking, oh my God, would that ever be easy with an optical printer to just put a moon in the background? Do what they did in Star Trek. You just outline it and make a mat and put the moon there. And there you go. Right now you have all these spacecraft orbiting the moon. No miniatures, models, or anything needed. Now, how simple would that be,
Yeah, should be very easy. It's the advantage of an optical printer.
Yeah, that's going to be the biggest thing is to see what's being produced, if they're calling it fantasy or fact. And at present time, we can only call it fantasy. It doesn't matter what they're doing.
They haven't proved it was fact. They've just proven it was fantasy, which is very sad, really. I don't think it's very long before NASA will come up front and say, yeah, we did fake it, and this is why. We'll see.
Again, I'm looking at the Apollo 9 footage. Again, with an optical printer, you could so easily map the background out and just put a moon there.
Yep.
You'd have the LEM floating above the moon. You would have the command module orbiting the moon, and all they have to do is just take the film in low Earth orbit and you're done. That's how they did it. And you don't need models. You're using the real thing. I never thought of that before until I started really looking at that footage. And I'm going, geez, you know how easy that would be to do that? Especially if you had a department of people that were outlining the craft to make the mats.
Yeah.
I mean, look at Star Trek. They did it on Star Trek, so you can't tell me they can't do it with a whole group of individuals that are outlining the craft and then putting it in the optical printer and put the filters on it. Yeah. It'll lower the background out so that you can put a mat on there, and then you could put anything you want in there and into the background, and it's going to look real. You don't even need models. It's just a thought. That's all it
And
is.
it doesn't have to be any better than any of the other images we've already seen.
No, because look at the LEM on Apollo 12, how it's just sitting there above the lunar surface. You know, I mean, all they would have to do again, have that thing on Earth, you draw a line around it and just put a mat there, and you just put the moon there instead of the Earth. Now, even when you look at the Apollo 12 LEM, or any of the LEMs that are kind of hovering over the lunar surface, I mean, the LEM's not rock solid. It's moving. Like, you could tell it's moving out of sync in some of the places there. So, come on.
I know. That's why they use Lookout Mountain laboratories. That's where most of this work was done.
Oh, that was staffed. I'll bet you they used that staff, or employed that staff, to do the outlining of all of the LM in Earth orbit and the command module in Earth orbit. That'd be so simple. I mean, look at that. They had an army of people working in there, and they have a connection with Disney.
You got all those guys that are doing stuff just because they're capable of doing cartoons, backgrounds and stuff like that, right? They can do all kinds of stuff.
Yeah, and they did.
They had individual artists for everything.
Extraordinary.
There was a few people in the comment section, they noticed that the lunar rover should actually be going faster. You have less gravity. You have no wind resistance. So why is it going in slow motion?
Well, electric motor, when you turn it on, is only going to spin so many RPM as well, right?
It should bounce higher than it appears to.
Yeah, but I can refute that by saying, look at the ones that they had in the desert. They were electric rovers that they had. They were the exact same rover that they were testing out there. Do you see how fast those electric ones are going out there? So why wouldn't they do the same thing on the moon?
The G2 trainer had a slightly different gearbox than the ones that they had for the moon. They had a different gearbox in it. So yeah, they did travel at a different space. And don't forget, you've got unlimited battery power when you're screwing around on Earth, because you can just go over to the trailer and grab another battery. Well, that's what they did anyway. I mean,
It's sad to see NASA being shown up by their own incompetence now.
Well, they should have got off the bandwagon a long time ago.
Yeah.
Brought everything back down to reality.
They've spent time doing imagination. Now it's time to get back to reality and tell us what actually happens.
What they should do is they should take whatever technology they're developing now, whatever they think they have, because they've created a few better materials to work with. I know they're doing that with Boeing and stuff like that for commercial aircraft and stuff like that. But it should be on the commercial market. If they have better insulations, they should be being put in our homes. Better UV radiation shielding in glass for houses and stuff like that. More efficient heating systems and cooling systems for households, that kind of stuff. Because they claim they have all of this for space on the commercial market.
Costs too much.
They'd make too much money doing that if they had the product. It's because they don't have the product. That's why it's not there.
And they got enough money to do it. Virtually unlimited budget. They'll say that Congress is holding back on their money.
And the best people. But instead of trying to put stuff into space, why not make our environment more efficient, living more efficient, having less of a carbon footprint while doing so? Because if you're burning less heating fuels and stuff like that in a population, and the same in cooling, you're using less energy all around.
But they don't care because they're not going to be around, so they're not going to worry about it. That's why.
It's not part of their mission statement. Their mission statement is to get to the moon.
They don't have an excuse anymore about the money and the funding, because right now they're getting all the money that they want.
Yeah.
This Artemis mission, they're hell-bent on getting this thing there right now. Did you see what happened? Last week, there was a video up. This was an official NASA video, and the woman was saying that they thought they were going to be able to do something by the end of this year. Now they've moved the Artemis mission to next year, December 2026. Well, they've been moving it back since 2014.
You mean Back to the Future?
Yeah.
I thought it was 2032 they moved it back to.
That would make more sense.
That's just humans one flight around the moon.
No, landing is quite different. Because they haven't even started on the Gateway project yet, have they?
As a matter of fact, they have 2 modules completed. The third one they're still working on.
Well, but those are just for the museums.
Well, yeah, eventually that's where they're going to be going. But again, They make all these modules. Well, it's going to take time for them to get them up there. And then not only that, but then they have to ferry them to the moon and then put them into orbit. Then they have to do spacewalks to build it. And by the way, this time they're not protected by the Van Allen belts when they're out there assembling those modules.
That's why they keep delaying it, because they can't work out how to protect them.
No astronaut worth his beans is going to go out there, especially with no belts and no protection. The Earth's atmosphere still protects them. The meteorites burn up. They slow down. No, not out there. They're not. They're going to get the full brunt of that impact.
Yep. And every CME within that 8-minute period, whack. Really good x-rays.
No place to hide, no early warning, because the flare hits the satellite that's around the sun there, or orbiting somewhere out there, is going to take 8 minutes for it to get back. So there's going to be a race to see who gets the information first. And then they have to retransmit that information to the Lunar Gateway Station, which is another 2.5 seconds. So really, they would have to be forward in time about 5 seconds in order just to receive it so that they could do something. And they wouldn't be able to do anything anyway. What are they going to do? Hide behind the water. That's not going to work.
Well, I was reading an article and it said it would take basically 45,000 x-rays to kill you. And then the CME was quoting that it was only blasting out the equivalent of 300,000 x-rays in a minute.
Here's another question that I want to ask. Why didn't the divers that were in the recovery team for all the Apollo missions, why didn't they have hazmat suits on when they were recovering these guys? Because they could have brought back some virus that they had no idea what it was. As soon as you open that hatch, guess what? You just let it loose to the world.
They did.
That's scary.
Except those guys coming out of there just got out of the beauty shop. Their hair's done, they're nicely shaved, their nails are trimmed, everything. They don't have a mark on them anywhere after traveling all that distance. They jump out, they don't have any physical effects on their body, they're not weak, they're not anything. So then they put them in the quarantine trailer on board the ship, and then they physically pick that trailer up and transport it off the ship, off the deck. They put them in there. They went to all of those type of things. Why didn't these guys have a decontamination shower?
Good question.
You see them get out of there and they march right into the thing. They've been 11, 12 days in space. They need to get cleaned up. They've been changing diapers that have been taped to their backsides. And then, of course, if you read the reports on it now, apparently they kept all of that and brought it back with them for scientific purposes, that they rolled them up and brought their excrements back with them. I'll say it like this, is pretty amazing shit.
It is, because what was left on the moon?
That's a refuge bag with the urine and stool samples in that bag. And yet you read another document and it said they rolled it up, taped them all up, and brought them back for scientific purposes, for biological study.
And where's the result of that study? Have you found it?
No.
No, because it never happened, because they left it all on the moon, we're told. Seeing as they never went to the moon, it would be much easier to roll it up and bring it back with them.
Well, there's so many anomalies, and I did send you the file on the Far Ultra camera. Now, if you can't see stars when you're on the lunar surface, and they don't show up in a photograph, this camera was designed to do other things, but how do you line it up?
Good question.
It was entirely mechanical, and when you read through that file on it, they're looking at different galaxies out there and moving it around, and it would take quite a bit of time to be able to line that up. But then how does it stay on to do a time exposure 15 to 30 minutes that the camera's doing that exposure?
It was the luck of Apollo.
Yeah, but they're moving. They're on the moon. Not only is it rotating around the Earth, but the Earth is moving as well. How do you do those calculations to even find those galaxies from the lunar surface?
It's the luck of Apollo.
Yeah.
Apollo had all the luck in the world.
And then all of these photographs that it was taking, and it has to be, the entire camera has to be manually reset. So if you have a time exposure of 30 minutes, you have to come back at the end of 30 minutes and reset this camera again to take the next photograph. But they're on the rover. They're out traveling, like they're not even close to this thing. And when they come back, they get inside the LEM. They're coming out of the LEM every 30 minutes to change the camera up. You have to have another guy there.
I would suspect that there was a lot of thought went into that. How would they manage to set the camera while they were inside the lunar module? Oh, I know. It was automatic zappers. They could point out the window.
Oh, I see. Or it was being operated remotely from Earth. You imagine in the transcript the conversation that would have to happen while they're setting this camera up. For each exposure, it could take 15, 20 minutes, a half an hour to set this camera up. Everything has to be reset to zero. It's a color plate that has to be inserted in there. I don't even know where those plates are that they're taking the picture with. When you see the number of photographs that they claim to have captured with this camera from the different galaxies and stuff, who's doing the calculations how to line that camera up? Maybe guys with slide rules on Earth would have to be sending that information up. I mean, they could level the camera and they could get the degree angle, they could set it, but they'd have to be told where that galaxy is. And somebody with some real genius would have to figure out where they are actually in orbit on the moon. They'd have to be there exactly.